Good morning. It's a very great honour to be invited to speak at this moment in this conference. I've deliberately chosen the title of my presentation to reflect the theme of the conference, but also because the relationship between evidence, values and decision-making is one about which I feel passionate. It is an inescapable fact that no country seeking to provide universal health care from their citizens can meet all the health needs of their people. None in either developed or developing countries have sufficient resources. The amount of money spent on healthcare varies very widely across the world. This shows the annual per capita expenditure on healthcare in Europe, expressed in international US dollars. It ranges widely, from Albania with about $600 per person per year to Luxembourg with an annual per capita expenditure more than 10 times greater. What is affordable in Switzerland, Norway or Luxembourg cannot necessarily be affordable in Albania, Macedonia or Romania. A similar variation is seen in South and Southeast Asia. And again, there is a massive difference between the expenditure on healthcare in Myanmar on the one hand and South Korea, Singapore and Taiwan on the other. The reason for this variation is simple. The amount countries spend on healthcare is what they can afford. Richer countries spend more on healthcare on a per capita basis than poorer ones. This shows the relationship between European countries' wealth expressed as their per capita gross domestic product and their expenditure on health. Albania spends very much less than Luxembourg on healthcare because it is a much poorer country. Indeed, differences in GDP in Europe account for 85% of the differences in healthcare expenditure. There is similarly a close relation between per capita GDP in South and Southeast Asia and on expenditure on healthcare. Countries spend what they can afford, and consequently, they have to make choices about where they spend their available healthcare resources. They have to make priorities. The critical role of HTAi is, I believe, to provide decision makers with the evidence upon which these decisions can be informed in an open and transparent manner. So the evidence for both clinical effectiveness as well as cost effectiveness are critical components of HTAi. The relationship between these two evidential components, effectiveness and cost, are sometimes depicted as a so-called cost-effectiveness plane. New interventions, less or more effective, are shown on the horizontal axis. New interventions, less or more expensive, are shown on the vertical axis. For interventions that are less effective and more expensive, a decision maker will clearly say no. For those decisions that are more effective, interventions more effective but less expensive, a decision maker will invariably say yes, although unfortunately these are uncommon. Interventions that are less expensive and less expensive might cause some difficulties to decision makers, but they are uncommon too. Most of the time, decision makers are having to evaluate interventions that are more effective but more expensive. And that's the job of HTAi, to assess the extent of these increased benefits in relation to their increased costs and consider what the opportunity costs will be if they are adopted. For in healthcare systems with finite resources, spending significant sums of money on one group of patients will inevitably mean that other patients with other conditions will be deprived of cost-effective healthcare. The evidence for examining the clinical effectiveness of new or existing interventions may be derived either from experimental or observational studies. By experimental studies, I mean, of course, randomized controlled trials, a technique that has had a major impact on modern medicine. But observational designs, especially historical controlled trials and case control studies, also have an important place. The design and analysis of conventional randomized controlled trials will be well known to this audience. It involves comparing the effects of two or sometimes more interventions that have been allocated randomly between the groups. And the outcomes between these groups are then compared at the end of the study. If the difference between them is so-called statistically significant, one treatment is considered to be superior to the other. The technique has three great advantages. It minimizes bias, especially selection bias, because every patient has an equal opportunity of receiving each of the treatments. It minimizes confounding, because as a result of randomization, these are likely to be evenly distributed among the groups. And provided the groups of an appropriate size, it minimizes the play of chance. Moreover, the statistical calculations are relatively simple, the methodology is widely accepted, and the criteria for significance are well established. But there are also inherent limitations and weaknesses. In discussing these, I do not wish to be misunderstood. I fully accept that randomized controlled trials have played a major role in 20th century medicine, and I expect them to continue to make equally important contributions in the 21st. Indeed, I myself have published the results of 19 randomized controlled trials, and I do not think I've entirely wasted my time. But randomized controlled trials also have limitations. First, there are some serious statistical issues. In particular, the design and analysis is almost invariably based on the null hypothesis, which assumes no difference between treatments. Only if the probability of the difference is less than 1 in 20, p is less than 0.95, is the null hypothesis rejected. The problem with this approach is twofold. First, the null hypothesis will only be of interest if the aim is to see if one treatment is superior to another. And although statisticians have developed superiority and inferiority techniques, these are not really suitable for the tasks demanded of them. And the p-value is too often used to distinguish between truth and falsehood. It doesn't. Second, randomized controlled trials are not necessarily generalizable to the circumstances beyond the population that has been studied. This is an especially serious problem when it comes to treating patients who, for one reason or other, were excluded from the original studies, the elderly, ethnic minorities, and those with comorbidities. Third, randomized controlled trials have now become outrageously expensive, and sometimes they are unnecessary. For example, there are many interventions for which the evidence of benefit comes exclusively, not from randomized controlled trials, but from historical controlled trials. Here are some. Historical controlled trials compare the effects of an intervention with what is reliably known about a condition or from a cohort of patients previously assembled and carefully observed. The use of colchicine for the treatment of acute gout was shown to be effective in ancient Egypt, although the active principle of colchicum was only discovered in 1830. It has been widely and rightly used ever since. And to take a more recent example, ganciclovir for cytomegalovirus retinitis. Cytomegalovirus retinitis is a condition to which patients with HIV and AIDS are particularly prone. Here is a normal retina, and here is one infected with CMV. In CMV retinitis, the lesions become confluent and cause blindness over the course of about a year from the onset of symptoms. In the mid-1980s, a new antiviral agent, ganciclovir, became available, and it was observed that it virtually completely arrested the progression of the disease and prevented blindness. We in Britain regarded this as adequate evidence for it to be given a license. Another jurisdiction, though, demanded evidence from a randomized placebo-controlled trial. 2 years later, the results of the trial confirmed what was already known. Ganciclovir arrested the progression of the disease and saved sight. But there was a high price to pay for requiring a randomized controlled trial. Patients in the placebo arm went blind. There were equally catastrophic consequences for patients with CMV retinitis who lived in the US, where ganciclovir was not licensed and therefore unavailable. They had to go blind too. Failure to accept evidence from randomized controlled trials can sometimes cause great harm. Case control studies, another important observational technique, involve comparisons of drug exposure among people that have and do not have a suspected iatrogenic disorder. The technique has been used to great effect in the identification of harms associated with medicines, and here a few examples are shown. They include venous thromboembolism with oral contraceptives, breast cancer with hormone replacement therapy, and atypical femoral fractures with biphosphonates. Case control studies have a crucial place in assessing the harms of therapeutic interventions. And they have also played a major role in sometimes demonstrating the absence of harm. You will all recall the publication of this paper in The Lancet purporting to show an association between autism and MMR vaccination, and especially the measles component. The first author of the study was this man, Andrew Wakefield. The other 12 authors subsequently retracted the paper, but not before immense damage had been done. The widespread publicity given to the study led to thousands of parents in the UK and elsewhere in the world refusing to allow their children to be immunized with the MMR vaccine. The consequences were predictable and catastrophic. As MMR immunization rates fell, so the numbers of cases of measles rose. In order to confirm or refute the association between MMR immunization and autism, several case controls studies were carried out, of which the most notable is that by my friend and colleague Liam Smeeth at the London School of Hygiene and Tropical Medicine. This forest plot shows Smeeth's findings in relationship to other but smaller case control studies examining the issue. None of the studies, individually or collectively, indicate an increased risk, and the overall pooled odds ratio confirms this. There is not the slightest indication that MMR immunization is associated with autism or other pervasive developmental disorders. Overall, therefore, both experimental and observational study designs have an important role in HTAi. Yet there are some, if not many, HT agencies that subscribe to the notion of hierarchies of evidence. Here is just one of literally dozens of hierarchies that have been published. They all place randomized controlled trials at their summit, with observational studies down near the foothills. They are widely used, not just by health technology assessment agencies, but also by public health bodies and guideline developers, to assess the quality of the available evidence and to inform the strength of any recommendations that they make. Here is another, with a 13-point scale, even more elaborate than the previous one, and again giving inappropriate prominence to randomized controlled trials and relegating observational studies to a lower rank. I loathe these hierarchies of evidence, for it is not the method that is important, but whether the particular method provides a reliable answer to the questions that have been asked. There are unquestionably questions about clinical effectiveness that can only be answered with randomized controlled trials. But my confidence in the effectiveness of penicillin in the treatment of lobar pneumonia, somewhere around level 4, according to this scheme, because its use is based on historical controlled trial data, is no less than my confidence in the benefits of statins in the prevention of myocardial infarction and stroke at level 1. Hierarchies are also incapable of handling mixed study designs, which are being increasingly used in decision analytic modeling. Hierarchies of evidence are at best unhelpful and at worst dangerous. In the assessment of cost effectiveness, there are 4 components that have to be considered: the so-called economic perspective, the type of economic analysis, the threshold used to distinguish cost-effective from cost-ineffective interventions, and the approach to resolve the problem of what political philosophers call distributive justice. First, then, the economic perspective: how the benefits, costs, and savings of an intervention can be apportioned, whether just to the budget of the healthcare system, or more extensively to include the benefits to families, public welfare services, or even wider society. These are ultimately political decisions, value judgments, if you like, with both advantages and disadvantages. Take, for example, in assessing the benefits of an intervention, the consequences for employment, what the economists refer to as productivity gains. It sounds superficially very logical, a treatment that may mean a patient can, for example, return to work. But it's not quite so simple, because unless there is full employment, when one person becomes unemployed as a result of ill health, an unemployed person gets a job. It ends up as a zero-sum game. And including these productivity gains will also, at least potentially, seriously disadvantage those who have retired. The favoured approach to estimating cost-effectiveness by NICE and many other HTA agencies is cost-utility analysis. In this scheme, the direct and indirect costs and savings are estimated. The benefits are expressed by the degree of improvement in the quality of life, multiplied for the time for which it is enjoyed. And from this, the quality-adjusted life year gained, the QALY, can be calculated. Dividing the net costs by the QALY gives the incremental cost-effectiveness ratio, the ISA. This approach has the greater advantage of allowing the cost-effectiveness of one intervention for one condition to be compared with that of another intervention for a completely different condition. Estimating the incremental cost-effectiveness ratio, the ISA, is one thing, but identifying a threshold distinguishing a cost-effective from a cost-ineffective intervention has proved more difficult. Indeed, there appears to be no or little consensus amongst health economists as to how this might best be done. Ranking the ISAs of all the interventions used in a healthcare system and making the threshold the point where the money runs out has been one suggestion, but we are light years away from being able to do it. Estimating the willingness to pay has been proposed, as it has in other fields such as transport economics, but some argue that its relevance to universal healthcare is limited. Another approach favoured by some UK health economists is to examine current expenditure patterns through programme budgeting to impute the point at which benefits are foregone if a new intervention is adopted. This must necessarily imply that all current expenditure is itself cost-effective. The World Health Organization has suggested that the ISA should be based on per capita GDP. And although there may be logic to some link with GDP, I'm not quite sure on what basis the linkage might best be made. And finally, there is the approach that we've used at NICE, originally basing our threshold on the broad judgment of the UK's health economists. Curiously, the various approaches based on the second, third, and fourth have yielded not too similar figures, and we at NICE seem to be roughly on the right track. And finally, the approach that HTA agencies should take to the problem of distributive justice. Distributive justice is concerned with the just allocation or fair allocation of goods and services in society, in this case, healthcare. There are three broad approaches possible. In the libertarian approach, it is the responsibility of individuals to provide healthcare for themselves and their families. It is society's responsibility to ensure that individuals broadly have the freedom to do so. This arrangement does not help those of us trying to provide universal healthcare. Utilitarianism seeks to provide the greatest good for the greatest number and to maximize the health of the population as a whole. Though emphasizing the importance of efficiency within a healthcare system, it does little or nothing for the health of disadvantaged minorities. Egalitarianism seeks for equality in access and outcomes. In healthcare, this sadly is unaffordable. There have been arguments about the most appropriate approach to distributive justice generally since the time of Plato, and I haven't found a solution either. Rather, at NICE, we have tried to balance the sometimes conflicting demands of utilitarianism and egalitarianism in establishing our social values, what one of my colleagues called muddling through elegantly. So when it comes to decision-making, the evidence is always inadequate, and judgments have to be made, and these fall into two groups. The scientific judgments relate to the science. Is the evidence for clinical effectiveness, for example, sufficiently persuasive? No study is ever perfect. All have limitations. So clinicians and other scientists have to be prepared to fill in the gaps. Is the evidence generalizable beyond the study population for use in the real world? Has the quality of life data been adequately captured? And so on. These scientific judgments are ones that members of at least our advisory committees at NICE are or should be able to make, and so should HTAi agencies. The second series of judgments are about social values. They relate to political and social sciences rather than the biological sciences. Should an extra year of life for a child be more highly valued than an extra life for their parents or grandparents? Is the end of life so precious that additional healthcare resources should be made available to allow people perhaps to enjoy an extra 3 to 6 months of life? HTAi agencies generally, and NICE in particular, has no legitimacy to impose their own social values on those who use and own their health service. We at NICE therefore established a Citizens' Council made up of members of the general public to help us define these social values. Our Citizens' Council is a stratified, semi-random sample of the population of England and Wales. Members were initially recruited by national advertisement, to which 35,000 people responded. Members serve for 3 years, with 1/3 retiring annually. At each meeting, NICE poses a specific question and arranges for various experts to address the Council and answer questions. Meetings last 2.5 days. The meetings are facilitated by an external organisation in order to prevent NICE's own staff from inadvertently contaminating the Council's deliberations. The Council is given time to reflect and deliberate before drawing conclusions that form the basis of a report. The report is published in draft form so that interested parties can comment, and after any revision it is presented to the board in public by one of the Council members. The Council's conclusions have formed the basis of a guideline for the use of the board and NICE's advisory bodies in drawing up its guidance. The Council's reports are available on NICE's website. Some of the topics are shown here. The report on age was one of the earliest, one in which the Council concluded that a year of life was just as precious at whatever age you are. This may well be a specifically British conclusion, and I'm not sure the same answer would be given by a Spanish, Italian, or Korean version of the Citizens' Council. On another occasion, the Council was asked whether preventing accidents happening to patients during their treatment, patient safety solutions, should attract the same monetary values as those assigned to benefits, or was patient safety special in some way? The Council said no. No more should be spent on preventing a patient's death than on saving his or her life by the use of a therapeutic intervention. But I'd make two additional points about social values and our Citizens' Council. First, our Council's conclusions are culturally specific. Consequently, it would be inappropriate to extrapolate them beyond the shores of the UK. Second, our arrangements have a potential flaw. For the Citizens' Council is only 30 members, and we rely on them to reflect the views of the citizens of the UK as a whole. The problem is that I don't know of a better way of trying to ascertain the views of the general public. Polling is hopeless because it just gives a snapshot of the uninformed, off-the-cuff opinions of another subset of the population. In my defence, I would point out, though, that the Council's reports are given wide coverage in the media. There has been virtually no criticism in either the professional or lay media of their conclusions about any of the problems we have asked of them. And here are some of the occasions when, in the light of the social values developed by the Council, we've exceeded the broad threshold range we use at NICE, £20,000 to £30,000 per QALY, to distinguish cost-effective from cost-ineffective treatments. Riluzole, which delays the need for tracheotomy in motor neuron disease, with an ISA of around £40,000 per QALY, was deemed to be an appropriate use of NHS resources because it provided valuable treatment towards the end of life for a condition that is largely untreatable. There are currently real problems in assessing health-related quality of life in children. It is often, therefore, almost impossible to estimate the ISA. For human growth hormone and insulin pumps, use in children appeared to make a substantial difference, and the likely overall budget impact was estimated to be modest. So our advisory committee said yes to both. In these instances, as in very many others, judgment plays a critical role in decision-making. Decisions should be evidence-informed, but the place of judgment, scientific as well as social, remains. Or as William Blake, an 18th century English artist, poet, and philosopher put it, God forbid that truth should be confined to mathematical demonstration. Thank you very much indeed.